Okay, today we're going to talk about solving equations. We're still doing solving equations, I should say, but this time we're going to have variables on both sides of our equation. And obviously, in order to be able to solve this, we need to have all my variables on one side and all the constants on another side. So I'm going to start off with this one. I'm taking a look at what I have. I have 2a plus 3 is equal to 3a. Again, please make sure you're taking notes on this as you go, and then, of course, answering the questions accordingly. So I need to, instead of my normal thing that I would have done, looking at, for example, the left-hand side and getting rid of 3, that's not going to do me much good because then on the right-hand side, I would have 3a minus 3. And I still wind up with having a's on both sides. So I'm going to take a look. I have a 2a here on the left-hand side, a positive 2a, and I have a positive 3a on this side. Well, I could do one of two things. I could either subtract 2a from both sides like this, because then it would cancel out on this side, on the left-hand side. This part would cancel out, and I would be left on this side with just a. That'd be one thing I could do. Or I could do subtracting the 3a. If I subtract 3a from this side, that means I would need to subtract 3a from this side. In which case, though, when I wind up here, 2 minus 3 gives me a negative a. And on the left-hand side, it gives me 0. So I really don't like that option too much. Number one, we really don't like to have a negative a. And number two, I really don't want something equaling 0. That's not really going to help me out. So we're going to go ahead and go with the first option. So kind of keep that in mind as you're going through and doing this. Try to see which would be the better option of which way to go. You can do it either way, but let's make sure what the best option is. It's going to be best for me to subtract 2a from both sides. Because what's going to happen is, and all I'm doing here is I'm not killing off a like we talk about. I'm just moving him to one side. Because remember, a needs to be alone all by himself eventually here, and because he's the star of our show. So I'm just getting them to be my like terms together. I can't have 2a on one side and 3a on the other side. I need to combine them. So I'm combining my like terms is what I'm really doing. This side we know cancels out because 2 minus 2 is 0. So what I'm left with is 3 on this side, a positive 3. We need to make sure we're seeing that, right? Positive 3. It's going to equal 3a minus 2a. We just can boil that down to 3 minus 2, which gives me 1a. And look at that. We're actually already done. We don't have anything else to do because we already have that 3 equals a. But remember, write it this way, a equals 3 with our variable first. All right, let's look at another one. A little bit more work maybe on this one here. Okay, we have 3v minus 8 is equal to 7 plus 8v. So taking a look at this, I have 3v. Again, I'm going to move my variable. That's the first thing I'm going to do because I want all the variables on the same side. So 3v and positive 8v. Which do you think I'm going to do? Am I going to subtract 3v from both sides or subtract negative 8v from both sides? Taking a look at this, I'm thinking let's subtract the subtract the 3v from both sides because this will cancel out right here and this will leave me with a positive v value, which I like, on the right hand side. So I have negative 8, because don't forget that sign, folks. See right there? Circle it if you need to. That's a negative 8 on the left-hand side. Equals, can't forget my 7 either. I have 7. Now what's happening here? We have positive 8 minus 3, which is going to give me a positive 5v. Okay. Well, now this is starting to look like what we're used to, because all I need to do now is get rid of anything that's with my variable. So the first thing that's going to have to go is what? If you said 7, you're correct. We're going to then subtract 7, because this is a positive 7, from both sides. Bring down my equal sign. This part cancels out, so we have a positive 5v. That's what we want. So I can just write 5v on this side. Now on the left-hand side, this is where the tricky part comes. Don't forget about combining integers. Let's circle them. I have a negative 8, and I have a negative 7. Remember, circling your integers or your terms are going to help you to remember what you're doing with your signs and hopefully getting your sign correct. Okay, so we have -8, we have -7. Remember, we're going to combine those terms. So in this case, because I have like signs, remember we're going to add and we're going to keep the sign. So my answer is going to be negative, and I'm going to add it up. 8 plus 7 is 15. All right, again, this is our two-step equation type of thing at this point. I need to still get rid of something. V has got somebody with him. He has to go. So I have to kill off the 5. The way to do that is to divide both sides by 5. Remember, we also kind of said about how V, the letter V here, is literally throwing 5 under the bus. If you want to think of it that way, just to kind of remember what you're doing there. So we're going to throw them under the bus. 5 divided by 5, we know, cancels out because we get 1V, and that's what we want. So we have V. And now we have to, again, think of our integer rules. If you remember, on this part here, we are combining. So this is either going to be adding or subtracting in this part. On this part here, you can clearly see that we are dividing. So this is our division. We have to remember there are a little bit different rules for combining and for dividing. I have a -15. I have a negative divided by a positive. We have to remember that what are we going to have? It's going to be a negative answer. And then 15 divided by 5, that's easy enough. It's going to be 3. You heard me say it already. And there is my answer. V is equal to 3. Again, oops, we should have done this. V is equal to -3. There we go. All right, let's try another one. Don't be freaked out if you have decimals in your answer or in your value. It's the same kind of thing. So we don't need to really worry too much about this. But again, I need to look at my x values first, my variables. Okay, so my terms with my variables is what I'm looking for first. I have a 3x, which is positive, and I have a 4x over here, also positive. Which number should I be moving? Am I going to subtract 3x from both sides or subtract 4x from both sides? I'm going to subtract the 3x because this is going to give me 0 here, which is fine. And if I subtract 3x from here, I actually wind up with exactly what I want, which is 1x right there. Because 4 minus 3 is 1, and it's positive, so it's an x. On the left-hand side, I still have plus 5, which is just 5. Now, I'm not done yet, though, because look what I still have on the right-hand side. I'm not finished. I still have to bring this down. So I still need to add to this 2.5. Okay, so now this is our one-step equation here. All I need to do is get rid of our 2.5. To do so, I'm going to subtract 2.5 from the right-hand side. And I'm also going to subtract 2.5 from the left-hand side. Keep my equal signs nice and lined up. This cancels out. I get x here. And 5 minus 2.5 is going to give me 2.5. Again, let's switch it around. So x is first. So x is equal to 2.5. Okay, sometimes you're going to come up with something that looks like this. Just looking at this, we're going to move the g's. In this case, we have a variable of g. I need to move one of them to one side or the other. They're the same g. It's one g on the left and one g on the right. Well, no matter how I do it, it's subtracting a g. So if I subtract g from here, I have to subtract g from here. If I subtract a g from here, I still have to subtract g from here. So either way, I'm subtracting g, and look what happens to my g's. They're gone. Ugh. All right. That means that I have 7 is equal to -3. Is this true, ladies and gentlemen? It's not true, is it? That means I have to put this here, because 7, as we know, does not equal -3. In addition, I need to write this. Here is my actual answer. There is no solution for this. And it makes sense, because if you have g, remember g would have to be the same value. So let's plug in an easy number. Let's plug in 2. If I plug in 2 here, 2 plus 7, that gives me 9. And if I plug in 2 here, 2 minus 3 is negative 1. They're not equal to each other. So no matter what I do, well, no matter what number I plug in for G, I'm still going to wind up with no solution. That is your answer. You still have to justify what you did. You still need to show your work. Make sure that you're showing you're subtracting a G from both sides, and you came up with the inequality, meaning it is not equal, and therefore there is no solution. All right. Let's see if we can do this one. A little bit harder than the other ones we did, because I have to combine some like terms and then get all of my variables on one side, and then I can finally solve my problem. So here we go. I'm going to start on the left-hand side because I read left to right, so I'm going to do my math from left to right. I have 2 C's, and also remember we're just going to start with our terms that have variables in them. I have 2 C's over here, and I have minus 3C here. So what is 2 minus 3? Negative 1. That means I have a negative C for this side. But I still have plus 4, so I need to put the plus 4. That's going to equal, and now I'm going to work on the right-hand side here. Well, C is all by itself already, so I don't have anything to add to C, but I do have a negative 9, and I have a plus 5. Okay, so I'm going to bring down my C first because we like to have our variable first. So I have a positive C, so that's just C. What is negative 9 plus 5? Again, integer rules, combining by integers. Negative 9 plus 5. You should have written negative 4. Okay, well now I can do some more work here. I need to get all my C's on one side. Since I have a negative C on my left-hand side right here, I think I want to get rid of him. I don't like negative values, right, for my variable, so I want to get rid of him. That means I'm going to add a C to him. If I do that, they cancel out. That means I also have to add a C over here on the right-hand side, excuse me. What is C plus C? You should have said 2C, because I have 1C plus 1C, that gives me 2 C's. So there's that, and I still have minus 4 over here. And don't forget on the left-hand side, I still have plus 4. So that's going to be 4 here. All right, so now I can do a little bit more work here. Since I need to get rid of the 4, this is a minus 4. That means I'm going to add 4 to this side, which means I'm going to add 4 to the left-hand side. This cancels out, makes my 0. And now I have 4 plus 4 is 8. Is equal to 2C. Okay, so now I need to get rid of my 2. That means I'm going to divide both sides by 2, or like I said, C is kind of throwing 2 under the bus, if you want to think of it that way, to get rid of him, because he's the star of the show. So that's gone. And again, I'm dividing the 8 by 2. So C is equal to 4. But again, let's write it with the variable first. There's my final answer right there. So again, we're just kind of kicking it up a notch with our combining like terms, and then also moving our variables to one side of our equation. It's just kind of kicking it up a notch to do that. We're still solving equations. We're still finding a value for the variable. Don't forget, you can always plug your variable back into the original problem to make sure you got it right. That's always a key thing to do. Hope you have a great evening, and I'll see you next class.